Hello and welcome to another Red9 demo. Today we're going to be going through something that has been on the list for development for ages and ages. It's been in code, we've used it for many different clients and wired rigs up, but we've never exposed it. And that is the IKFK matching systems. Now the UI has always had this first one, process, and that is basically expecting a rig to have the node set up so that the IKFK can match and work. But what we're now doing is exposing the actual process of setting it up so it will work with any rig, your own custom rig, your studio's rig, whatever. And before this happens, you need to know a little bit about the networks and the understanding of what a Red9 ProPack rig is or what it's expecting. This is a system level thing. So if we're doing an IKFK switch, we're going to switch an arm, or we're going to, the arm is a system. The leg is a system, the spine is a system, the head is a system. And the idea is you have separate subsystems and you're switching within that system. And that's quite important to understand. And to do that, I'm going to close this down. I'm going to open up two UIs. One is the Rig Manager UI. You'll see this says unconnected. And the other one is the Metanode UI, which again has nothing in it. Now, although this is a Red9 Puppet, I've stripped it back so it is effectively just a custom rig that we don't know about. That's the important part of it. And you'll see in the UI it says unconnected. So I've got two options here. If I want to do it quick and easily, I can just select that, and we get shown a number of base M node types. The top one is external. That is effectively, I just want to quickly wire this up. I don't care about subsystems or orders. I just want to wire everything up so things like the animation systems work, the rig manager, sorry, the Red9 anim, etc. work, but I'm not bothered about it being granular or intelligent particularly. But what we need to do is we need to use ProMeta because we're delving deeper into the systems. So we can do this one, ProRig. Now if I refresh that, you'll see we've now got a ProRig node, and it's just a network node, but it's not connected to anything. So in order to add a subsystem, so we've got the main mrig node, and I want to do a subsystem. So I'm going to add this left arm into it. So I'm going to right click on there, and I'm going to go add child subsystem. Name, I'll call it left arm, and it says what sort of type it is. That's used for some other bits and bobs within the code base. And there's my arm. So I've now got two nodes. And what I can do on that is I can then select my controllers with that selected and go connect. Now that will effectively connect those controllers to that arm system. And that's kind of the level we're after. There is a much easier way of doing that. So I'll just delete those. So again, we're back to square one, refresh, nothing about it. And go file import base networks. So this one here, base Red9 Puppet networks. Yes. And what that's done is that's imported, or that's built, I should say, the base system. So there's the arm, sorry, there's the mrig, excuse me. There's the arm, there's a finger system hanging off the arm, there's the spine, there's a head system hanging off the spine, fingers and legs, etc. That's kind of the base network that for a standard biped we'd expect, okay? And let's go back to the arm. So let's get the arm included into that properly, and then we'll move on to the actual IKFK matching. So what I'm going to do is just add in these controllers. Again, you have the system selected, right click, connect. This node, this name here is quite important, particularly that one, the underscore, sorry, the CTRL underscore. That's really important. Don't change that. Node name you can change, but the CTRL, do not change that. Don't mess with it. So I'm going to go yes, and obviously we need to get the FK into that system. So we'll just switch. And we'll select the FK controllers, right click, that one there, connect, node, done. Now then, if I double click on there, all of those controllers highlight, and that's because they're now connected to the ARM system. So we technically now have a system that's capable and viable for IKFK matching. I'm not going to go into these, we've done that before. At some point we'll do another video where we properly go through this whole process, but I just want to kind of give you the flavour of what it's expecting. So at that point I'm going to come back into IKFK match. And if I come into the setup tab now, you'll see we have systems. Because we've added those systems, we've added all those base systems. None of them have connections apart from the ARM system, which we now know has connections. Okay, so we'll get this set up. Now I've hacked the rig. By default, we use IKFK blender, as the attribute that we switch between IK and FK. And when that value is 0, it's in IK mode, and when the value is 1, it's in FK mode. In this particular rig, I've modified it so it's called IKFK switch, and I've done that on purpose because what you can do is you could look at that and you could go, well, that's called IKFK switch, and you type it in from here as it is here, FK switch, but that attribute doesn't exist because that's the nice name. So what the best thing to do, and what we always do, is you grab the attribute, change it, come into the script editor and copy it from there. That's the actual name of the attribute that we're interested in. I'm going to put that in there. Okay. Now, value of 0 and 1, that's correct. In ours, 1 is FK, 0 is IK, so I'm going to leave that. And then I'm going to set the switch controller. The switch controller is a thing that has the attribute that we're controlling in the first place. Now, if I, for example, select something that isn't in the system, this is why we're saying about everything has to be in the system, and we go set, it will tell you, aborted, selected node is not part, is not part of the, sorry, he's not throwing me. The selected node is not part of this subsystem, so it's already saying validation has failed. So we're going to give it the one on the left arm, because obviously we're dealing with left arm here. Now then, at this point, nothing is set. This is all UI-based stuff that we've set within here. And this is red, that's why that is red, because there's nothing bound to this node. So what I'm going to do is I'm going to select that, I'm going to go set, and if that turns normal color, at this point, that means that the IKFK management is already in play. So this switch attribute is already being managed now, so is available to manage. So what I can do is I can come in here just to test, I can go switch mode, and there switch mode. You'll see these modes are now switching. Look, so we go to IK and we go to FK. Now that's the base of it. What we now need to do is give it the references. So give it the nodes that, if you like, that we're going to use as reference to how and where these IKFK controllers should be in each state. And I normally start with the FKs because it's just easier. So we're in FK mode. Now what it's expecting is something within the rig that represents where that limb is in IK and in FK state. So when we're trying to do it for the FK controllers, we need a node within the rig that is in the right place that the IK would be, that we're about to use to reference for where we're switching to, where we're getting the data from. Now internally we do it a lot more complicated. We have two sets. We have an IK, we have an FK, and we have what we call cast. And we've decided when we're doing this UI, we're only going to use the cast method because it just makes things so much easier. And cast basically says, this skeleton, inside ours at least, this is the output skeleton, so this is the main, it's not the deformation skeleton, it's the output skeleton. This is always going to be in the correct state, regardless of whether I'm in IKFK mode, and that's why it makes it easier. So what I'm going to do is I'm going to use that. So there's my upper controller, sorry, there's my upper joint, there's my controller. So I'm going to start at the top and walk down, 1, and I'm going to go for the next one, 2, and I'm going to go to the wrist. 3. Okay, that is it for the FK. So that's the FK matching over to the IK fixed. I'm going to switch into the IK mode, and I'm going to do the same, but I'm going to do it in order, and the order is quite important. If, like us, you have something like a pole vector that's automatically solving itself, it's solving based on where the wrist currently is, and it'll solve itself. So if you were to snap the pole in place and then you snap the wrist, that pole would move out of whack because it wouldn't be solved in the correct order. So you have to think about the order these things are solving in. And in our case, we're going to solve the wrist. Normally you'd solve a wrist first, or you'd solve the foot first, and then you deal with the other systems. So I'm going to do that, and then I'm going to solve the pole, and I'm going to solve the pole to the upper joint, which is the joint that runs down here. And the reason for that is it removes any twist that the wrist puts in that way on the twist joints, it removes that from the pole itself. Which usually gives you a better result. Okay, so we've got our IK, we've got our FK, we've got our match points. These things are as an order. I was just saying about the order of it. If you want to change the order, for example, if we've done it wrong, you can just switch them there, and you'll notice actually it's refreshing here, so it's this match point index. That's what it's using to deal with it. Now, at this point, we effectively now have a system that can IKFK match. So if I come up here, and I come back into the other side, and I refresh it, these two turn yellow. That's what we need. We want these to turn yellow, which basically means we're all set. I'm going to turn off the match over the time. I'm going to turn off that because I just want to show you the switching happen. And we're just going to go cast. And that's it in FK mode, and that's it in IK mode. It's as simple as that. If we want to do the foot, for example, we'll do the same thing. Let's just add the foot systems in very quickly. Open the node UI. What do we say? The foot. Where are we? Left foot system. So we'll select that. We'll add the controllers into that system. Again, just to show you how quick it is to do. Those three. Add, where are we? Add. Yes, whatever. Select that. We'll switch over to the FK. 1, 2, 3. Add those. Add. Yes. So those are all marked up. If I come back into here, I'll go back to setup, select the leg, left leg system. Again, this is all wrong because it's not what we usually expect, and I've modified this rig. So I'll just grab that attribute again. Grab that. put the switch, set. This is red because it's not actually bound to that system yet until you hit the button and it pushes it into the system. And then again, we can do the leg, so we'll come down to where we've got a separated hip on this, haven't we? So there's the leg, there's the FK, switch FK 1, come down, lower, 2, come down, foot, 3, switch to IK, switch the mode in there, get my leg control. Actually, no, where are we? We're going to go foot, then that one, and then that one, oops, that one, and then the pole. Done. And that's the foot done. Sorry, that's that leg system done. So again, we'll just do that, come back into this node, and we'll go cast to FK, cast to IK. It's as simple as that. So the takeaway is basically we have this idea, this complex idea of subsystems, but actually it's not a big deal. It's not scary. The wiring that you do within those subsystems, you can store and save back in. So this save mbrig networks, that stores the connections and stores that map of connections. So you can do it once and actually just save it off. That's really useful. And like I say, it's basically wanting these two set up. So we're having this part set up, you select the subsystem, you give it the controller, which is the one that's got the attribute you're switching, set the value so it makes sense within what range you're using with IK and FK. And then you go in and set the points. And if you want to see where the points are, you just select them in here. These are the points. If you do that, that is a controller it's physically selecting. And the really easy one is if you actually wanted to debug it, that's as simple as it gets. So there's the leg support system. There's the match point. So this is an FK match point. And that FK match point is connected to the controller that it's actually going to use and snap. And that is the reference point for where this should be when it's switching to FK. And that's parented underneath the foot, sorry, underneath the lower leg. Hopefully that makes sense. It's like I say, it's new in this version. We've got a couple of clients trying it out at the moment. They seem to be getting on quite well. They're using it with Advanced Skeleton. If you right click in this attribute field incidentally, there is a setting for advanced, so that automatically sets your attributes and your IKFK values to align with what Advanced Skeleton is requiring. Okay, that's it. Short and sweet. Hopefully we'll probably do a few more based on this, or a certain when we're doing the more complicated networks, but that should give you a taster for it and should hopefully get you up and running. Thanks for watching. See you soon. Oh, don't forget to like the channel and YouTube and all that kind of thing. And if you want to grab ProPack and try this, go away and grab it. It's on the website. There's demo versions there available, and it's on subscription, so it's dead easy to get. Thanks very much. See you soon. Bye.